Hello, myself Dr. Kode Jaya Prakash, working as Senior Assistant Professor in Department of Mechanical Engineering at VJEC. Today's topic is on reverse engineering in additive manufacturing. So in this, I'm going to discuss about this, what is meant by reverse engineering, what are the techniques we are going to have in the reverse engineering, and how that reverse engineering plays an important role in the additive manufacturing. So now, what is meant by reverse engineering first? What is the main purpose of this reverse engineering? So reverse engineering, I can say that it is simply opposite to the forward engineering. Means that suppose if the CAD model is not there, and suppose if the concerned company wants to upgrade their old model. So if the CAD designs are not existing, so then there is a role of having for the reverse engineering. So what exactly here we are going to do is that, so instead of doing the CAD modeling, the old part is going to be scanned. The old part is going to be scanned. So including outside features and the inside features also is going to be scanned. And then that data is going to be obtained and going to be processed in the reverse engineering software. So this, especially this reverse engineering is going to be, simply I can say that it is a scanning or digitizing the parts or products. So by this, it is going to helps you redesigning a component without having the CAD drawings. This is the purpose of this reverse engineering. Now coming to the case of this, as you can see that in this first is original model, and is going to be, and suppose if you want to improve the previous old parts, previous old models, so then if the drawings are not there, then it is going to be scanned and then it is imported in the CAD, and then it is going to be processed with the help of features, adding of the features, and then it is going to be sent to the remaining conversion to STL and then sending to the RP machine or 3D printing machine. So why this, I told you this, so generally, what is meant by this reverse engineering? So what is a forward engineering? So generally, the engineering, the drawings, whatever we are going to do with the help of the bills of materials, this without the engineering data. And reverse engineering is that is a process of duplicating an existing part. It's like just like scanning of your papers, just like A4 size papers. You are going to scan in the PDF, get in the PDF. So just similarly, exactly the same process. We are going to scan the physical objects. So there in the previous classes we had seen is from STL file we are importing, and then finally the physical part we are going to obtain. But here physical part to the digital part we are going to be obtained. So that digital part, whatever it is obtained, is going to be processed in the CAD software, and then it is converted to STL, and then it is going to be sent to the printer. So there digital to the physical part. So here physical to the digital part. This is where the difference between the actual RP techniques and that reverse engineering technique, which is synced to the this RP techniques. Now here, so just like that, what is the reverse? What and in what ways it is going to become a solution? So as these products become more organic in the shape, that is that designing in the CAD becomes more challenging. This is where the reverse engineering is going to be considered as optimal solution. The physical model is the source of information for the CAD in the reverse engineering. So it is also helps in compressing the product development lead time. So this is the main solution why we are going to go for a reverse engineering. And here I told you that physical to the digital object we are going to obtain it. So this is a simple example of some injection molded part is going to be scanned and then it is converted to the digital model. So why the use of this reverse engineering? The original manufacturer of a product is no longer produces the product, or the CAD designs are not going to exist. There we are going to choose this reverse engineering. So here, if you want to improve the features, also you can able to work out on the features and going to if you want to analyze the good and bad features of the competitors of the products, and if you want to explore the new avenues to improve the product performance, also this reverse engineering plays an important role. So here, this is the sequence of this reverse engineering process. Such input is going to be taken from the physical part, and the data is going to be captured with the help of either CMM, coordinate measuring machine, or laser scanner, or optical scanner, or MRI, or stereo scanning. So these are the different reverse engineering equipment which is going to be used to scan that physical object, and then the scanned data is going to be obtained in the form of point cloud data. So means that it is a completely the mesh format, and then later on after processing into the mesh format. So we need to, because while doing the scanning, the objects which is other than scanned parts also is going to be captured. So that all those factors are called as noise factors. So these noise factors should be completely eliminated, and then whatever part which we are supposed to retain, you can able to retain those parts. And then so that model either can be converted into .stl or can be imported to the CAD format to improve the features, to work on the features. And coming to the case of end applications, is going to be used as a CAD system or CAM system, and CAD CAM and CA systems. So this is the sequence of reverse engineering process. So this is a workflow, as I told you, just like the same, just a similar flow diagram. So this is capturing of the data, process of 2D or 3D data, and then obtaining the CAD geometry and creation of the design or modification, and then followed by inspection, analysis, or export to the 3D print. This is a sequence of workflow. So suppose the same thing, so this is applicable for the engineering applications, but whereas already we are aware of the medical applications. Why? So what is the process of medical application? So I suppose if you want to scan, if you want to print or inside our body organs, then the data is going to be extracted from CT scans or MRI scans, and then the image segmentation is going to be done using certain medical modeling software. That is, in one session I explained about the softwares for additive manufacturing. In that sort of, the medical software is going to be taken, and that data is going to be processed, and then whatever the interface we are required is going to be processed, and that surface reconstruction is going to be done. And again, if you want to import in the CAD model, you can able to work out on it, to work out on the features, and so that proper BioCAD model is going to be prepared, and then it is converted to STL, and that is sent to the concerned 3D printer to print that physical object which is scanned inside your body. A physical part, I can say a physical part which is scanned inside your body. So this is the process flow in the medical field. So what are the phases of this reverse engineering? So first one is the scanning. So this 3D scanning is going to be done. It's going to convert into point cloud processing and multiple scan alignment, because the scan is going to be obtained in the form of patches. So all the patches are based upon the physical object, whatever we are going to see. So that alignment has to be done properly. So all this alignment is going to be done properly with the help of point cloud data processing. And then after that, we are going to apply this features of the CAD models, and then later on to work out with the STL file, and then we are going to go for the printing of the parts or objects. So scanning phase is going to be done with the help of contact scanners and non-contact scanners. So contact scanners means that, and suppose if you want to obtain the features of the physical object, there is a machine called as a CMM, equipment called as CMM. So that CMM is having the probe. So thus that probe is in contact with the surface geometry of the part which we are supposed to obtain its features. So that probe is in contact with a certain feature, and that probe, whatever data is going to be captured, it is going to be seen in the system, and based upon that, the scanning process is going to be done. And whereas if you go for non-contact scanners, that is a blue LED or lasers, certain sort of light is going to be focused on the surface of the model, and then that patch data or point cloud data is going to be obtained in the system, and then based upon that, it's going to be processed in the software. So that's contact and is a non-contact type of scanners. As you can see, this data acquisition methods, that is for non-contact methods and contact methods. For non-contact methods, it is going to be done with the help of magnetic, acoustic, and optical. So in this, optical is again divided into laser triangulation and time of flight and interferometers and structure lighting and stereo analysis. This is where the optical scanning is going to be done. But whereas with the tactile methods we can able to use for either CMM or robotic arms. That robotic arms is also equipped with the probes, and that surface, whatever the probe is going to be contact with that surface, and that data is going to be captured. That CMMs also having the probe. Same thing, same probes is going to be attached to the robotic arms. But with the why they are going to go for robotic arms method to obtain the several degrees of freedom. So this is the reason why it is going to be used for non-contact methods and tactile contact methods. And contact scanners, you can see this. The CMM probe is in contact with the surface of the model, and then these features are going to be obtained here. As you can see this. And non-contact scanners, as you can see this light is going to be focused on the surface of the entire model, which has to be captured, and that data is going to be captured and going to be processed in the software. As you can see this small video here. Yeah. Now I'm going to show you this contact scanner video. As you can see here, so how this CMM probe, how this probe is going to be in contact with the surface of the workpiece. As you can see here, so this is the scanning is going to be linked with the system concerned software. So you can see this how the features are going to be scanned in each and every contours. As you can see here, is going to be processed with the concerned software, and they're going to make this sort of on how the contact features has to be scanned, and how that alignment is going to be done. You can see here, this is how this contact is. So as soon as it is in contact with the surface, as you can see there's a point coordinates is going to change, and how each and every surface is going to be scanned. As you can see. So this is the first feature is going to be scanned, and then followed by the second feature is going to be scanned. So this techniques is called as contact type techniques. Contact type techniques, and how that is, see here, see change of the coordinates. And then so after obtaining all these features, and then then he'll go for the other features, which is going to be, which is yet to be scanned. You can see that all the features are scanned, and then this proper alignment and working of the coordinates and accuracy is going to be seen twice. All the features you can see here. So each and every feature, when the probe is in contact, you can see that scanning is going to be done. So there is GD and T tolerances, whether it is maintained with the proper dimensions or not, is going to be seen. So this is the called as contact type method. And whereas coming to this video, I'm going to show about this non-contact type. So this is RTech 3D scanner, and how that RTech 3D scanner is going to be scanned with the help of a blue LED. So as you can see here, so that light is going to be focused on the surface of the scan part, and that data is going to be formed in the form of point cloud data. You can see that working on the features, and that rotary table you can able to rotate to scan in all directions. You can see this is going to be the scanned up data is going to be processed in the concerned software. Working of the reduction of the noise factors and usage of multiple tools to process the entire part. And here he is going to display the different options to work out on the noise factors. Noise factors, as you can see here. And in this way, this the part is going to be processed, and it's almost equal to it takes more time than the CAD modeling. So it is not that much simple as CAD model, but it takes much experience to process all the features. Yeah, this is how this CAD model, the physical model is going to be replicated using the 3D scanner. And this video is also one more non-contact scanner. So how that big parts is going to be captured with the help of a laser light, which is going to be focused on the surface of the physical model, as you can see here. So how that capturing is going to be done, you can see in the system also. So this scanning techniques should have the lot of technical experience, and how we are going to scan, in what pattern we are, the scan has to be done, etc. And later on, working on the there's a processing of the noise factors, etc. As you can see here. So this is how it is going to be scanned, and then working on the noise factors. So they're going to apply the several tools to work out what the holes also it is going to be captured, as you can see here. This is how these holes are being captured, and then working on the noise factors. So this is called as a raw data, which is going to be obtained from the scanner, and then there's a pre-processing techniques to remove that raw data and to get the fine features details. As you can see here. So this is the final view of the file which is going to be processed. In this way, the physical objects are going to be scanned. And that just one more scanner. There's a non-contact type. So how that big pinion gear is going to be scanned. So this pinion gear, all the surface features, how it is going to be scanned. And here you can see this, the pinion gear, because if you're going to scan with the metals or anything, whatever you're going to scan, it's better to apply the developer spray. So why we are going to apply this developer spray is that to avoid the reflection. Because if reflection is being done, then scanning of the physical part it becomes quite difficult. So that is why developer is very important to spray on the surface to be scanned, and then all the features are going to be obtained here. And then same thing, there's a processing of point cloud, as you can see here. See how each and every feature is going to be scanned. This requires precise experience also, where to start and where to end, etc. And how to avoid this noise factors, as you can see here. And whatever the scan area is missed, again we need to work out on the area which is already missed here. See, after obtaining that one, then it is going to be, you can able to send that file towards that CAD/CAM CAE to work out on the. So we're going to apply this how that the scanned part is going to be analyzed. So analysis of CAD/CAM CAE softwares. So now this what is this point processing? Just a continuation of the PPT. So this point processing is this phase involves the importing of point cloud data, and how to reduce the noise data which is collected, and reducing the number of points. Especially these options are going to be performed using a wide range of predefined filters. So it is extremely important so that users have very good understanding of the filter algorithms. So this phase is also allows us to merge multiple scan data, and this multiple planning is going to be set with the direct impact of the point processing phase. So here good data planning for multiple scan data is required, which is going to reduce the effort for the time required to do the point processing. So the output of the point processing phase is a clean merged point cloud data and is set to the most convenient format, and then that format is going to be used for CAD/CAM CAE softwares. So this application of geometric model development, and this involves the importing of the design CAD model and superimposing the scanned point cloud data in the set of manufacturing part. And here in this software is going to allow the user to compare the two data sets. One is designed to has to be manufactured, and this process is also going to be used for inspecting the manufactured parts, and whatever the file which is going to obtain, so can be converted into different format which as per our requirement, either IGS or VDA or STL or DXF format or OBJ format. So this generation of the CAD models from the point data is probably the most complex activity. So within that reverse engineering, this is the most complex activity which requires much skill is required to perform this sort of activities. And coming to the case of advantages of this reverse engineering, so reverse engineering typically starts with measuring an existing object so that a solid model can be deduced in order to make use of the advantage of the CAD/CAM CAE packages. And also it is going to reduce the cost and lesser maintenance cost and quality improvement and competitive advantages. So these are the main advantages are going to be explained for the engineering, reverse engineering. So in areas of application, designing of a new component, reproduction of an existing component, and for improving quality and efficiency of the existing parts. And coming to the case of manufacturing engineering, especially it is used to create a 3D virtual model of the existing physical part and to make a digital 3D record of own products and to access competitors' products, etc., to identify potential patent infringement, etc. And for software engineering and chemical engineering also, these are the fine advantages to extract the design and implementation information to detect and neutralize viruses and malware for software engineering, and for chemical engineering to determine chemical composition and to substitute or improve recipes to simulate or improve the product's performance. And film and entertainment in industry, here the person is going to be scanned, and then it is going to be that scanned is going to be applied for that for persons, for the dubbing artist, and then so duplicacy of the persons can be able to done using this reverse engineering techniques. That is called as a human scanning. So human scanning is completely different from this engineering scanning and the medical scanning. And in the case of a medical field, the applications in orthopedic, dental and reconstructive surgeries and imaging, modeling and replication of the patient's bone structure, and also less risk to the patient and reduced cost through the saving in theater time. So thank you for listening my session on reverse engineering. Thank you. Thanks a lot.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.